to you, my dear friends. In this today topic we are going to see about uniform convergent problem in real analysis topic. In this concept we are going to see one very important problem which is very easy. From that problem I'll explain you the entire concept of uniform convergent, how to find and what is uniform convergent, pointwise convergent, everything, which is useful for all CSA, NET, GATE, IIT JAM aspirants. Also set TRB Polytechnic, they can also watch this video. Welcome to my YouTube channel Just in Math and Math in Just. For n greater than or equal to 1, let fn of x is equal to x e power minus nx square, x belongs to R. Then the sequence fn is, which is the question. Here the question is fn of x is equal to x e power minus nx square, which is the problem, which is the function they have given to us. Now we have to find what is that, whether it is uniformly convergent, bounded or not uniformly convergent, or unbounded function. We have to find all those concepts. Before that I'll explain you what we have to find first. Once they have given uniform convergent, we have to find whether it is pointwise convergent or R, because every pointwise convergent or uniformly not like that, every uniformly convergent or pointwise convergent, but converse is not true. But without checking the pointwise convergent, it's quite hard to find the uniformly convergent. So first we have to find the pointwise convergent. So let will find. Before that I'll say you the answer. We will see the solution later in next slide. The answer for this question is answer 1. The given function fn of x is equal to x e power minus nx square. First we have to find the pointwise convergent, as already I have said. So for pointwise convergent, nothing, just we have to check the limit function. Limit function means nothing. Limit n tends to infinity we have to apply. After that we have to check what's the value it is giving. So same way I am applying here. In place of fn of x, I am applying the given function. I am replacing according to my convenience. It gives the answer 0 because e power n tends to infinity, nx square, e power infinity. So x means any number which divides infinity, which gives 0. So here the point limit, the pointwise convergent is true. The limit function is 0. Now we have to find uniform convergent. For uniform convergent, there is a law, there is a principle which is called the Mn test. The Mn test is nothing, limit n tends to infinity, supremum d, fn of x minus f of x. Here this f of x means limit function, which is already we have find in pointwise convergence. So now we have to do what is supremum d, that's what we have to find. Now let's apply our given function. Now we have to find supremum of d. For this question, what is the supremum value? That's what we have to find. As we all know how to find supremum, let me show you. First we have to take y is equal to x e power minus nx square, replaced. Then we have to find first derivative. What is first derivative? This is what that answer. And final solution is for y dash 1 minus 2 nx square divided by e nx square. Then we have to apply y dash is equal to 0. Then after applying, I am getting the x is equal to plus or minus 1 divided by root 2 n, which is the stationary points. Now I have to do y double dash equal to 0. So I am taking y dash and I am applying the derivative. After applying the second derivative, I have to put for x 1 by root 2 n. This value I have to apply that. So I am applying that. So I'll get 0. How means in place of 1 minus 2 nx square, if I apply 1 divided by root 2 n, it gives 1 minus 1. I show you how here. 1 minus 1. So the entire term will become 0. We'll get only the first part. Before sum we'll get. So however it gives the negative value, so it's less than 0, so it is the maximum point. So we have find the supremum of the given function, which is x is equal to 1 divided by root 2n. Now we have to apply this x in our function, which is the point of maximum. Now here we have to apply in place of x. After applying, we have to get 0. If you are not getting 0, then it is not uniformly convergent. So from this we will say which is uniformly convergent. It is the uniformly convergent problem. So option A is true. B and C are false, but we have to find whether the given function is bounded or not. By uniformly convergent, we can't say whether the given function is bounded or not. So we have to find that one also. Before that, I'll tell you the shortcut method to find the supremum value. You no need to do this much of y dash, y double dash, y dash is equal to 0, the stationary points. Then second derivative I have to find, and again I have to apply those concepts. So it's the very big one. So we no need that much. It's a small trick, just apply. If we get the answer, just for infinity, just keep in mind it's just a memory process. For infinity, x value goes to n. For 0, the x value tends to 1 by n, which gives 0. This is what happens. So now we put x is equal to n in our place. So what we'll get? If we apply x is equal to n means for n tends to infinity, in place of n, if I apply 1 means 1 divided by 2.718. Actually E value is 2.718, which gives the value 0.3679. 2 divided by 2.718 means 0.099. So if the value goes to infinity means surely it reaches to infinity. Sorry, it reaches to 0. So it is uniformly convergent. Now we will discuss the boundedness. Then only we can conclude whether the given or the option D is true or false. Function fn is bounded on R if there exists a constant mn greater than 0. There have to exist one mn which have to be the constant value, positive integer, natural numbers, that have to be the boundedness. It wants to have the limit. Let's check whether it has the limit or not. Fn is a sequence of bounded function if every function fn is bounded. Fn of x equal to x e power minus nx square. X belongs to R, n greater than or equal to 1, which have to be less than at one point. The entire function value is below that point, means it's bounded. Whether we will see it happens or not. Actually, which is less than 1 only. As we have already checked also, the entire function is maximum value is 1 and below that 1. So we will say the function is bounded. So option D is false. Once again I will show you the question. Uniformly convergent we have proved. Uniformly convergent only on compact subsets of R need not be, because it is uniformly convergent on entire R. And bounded and not uniformly convergent, it is also true. It is bounded as well as uniformly convergent on R. A sequence of unbounded function, which is also false because it is the bounded function. So answer 1 is correct. Thanks for your time, friends. I hope you like this video. If you want tell any suggestion, please do comment, and please subscribe, like and comment the video. If there is any correction, please tell me. I'll correct it myself. Thank you.